Alrighty. Good evening, everyone, and welcome to our 7th Turf Club meeting for the fall of 2020. For those of you who don't know me, my name is Kyle Masters. I am the president of the Penn State Turfgrass Club. I'll let the other advisors and officers introduce themselves as well.
Hey everyone, my name's Landon Hall. I'm also the vice president of the Turf Club.
Hey guys, name's Ben Rita. I'm the treasurer.
And I'm AJ Wow, and I'm the secretary.
Awesome. All right. Well, everybody, thank you for joining us again today. Tonight we have a very special guest, Mr. Paul Roche from Gulfwater. And Paul is here to talk about his experience in irrigation in the turf industry. So Paul, thank you for taking the time out of your day to talk to us, and welcome.
Thank you, Kyle. It's my pleasure. Thank you, everyone, for allowing me to join you. It's a great pleasure. Kyle asked me if I'd speak on some golf irrigation, which is a topic that is near and dear to me. So I'm going to get right into it. I know we've got about an hour, so I've got a few topics I'd like to share with the group. And of course, I welcome any questions whatsoever. Feel free to stop me, ask me a question. I might even have a few questions for you guys as we go through some slides here. My name again is Paul Roche. I'm the founding partner of Gulfwater. We're a golf course irrigation and consulting firm. I first got into the business right after college. I went to the University of Massachusetts. I was a turfgrass science student, and where a lot of my friends graduated and went on to the golf turfgrass management field. I went right into golf course irrigation back in the 1980s, and that's all I've done in my professional career. I've worked in distribution. Actually, my first job was actually as an irrigation draftsperson before the days of AutoCAD, when we used to do hand drafting, and worked my way through distribution, spent some time in manufacturing, and have really enjoyed getting involved in irrigation consulting. I first met Kyle back, I think it was the summer of 2018, maybe 17, 18. At Marion during their restoration project. And then again, had a great chance to bump into you about a year ago at Oak Hill Country Club in Rochester during their renovation project as well. And had a chance to work on some great projects across the country. Today I wanted to talk about a few things. I tend to get asked similar questions when I visit with golf courses, and they also want to know about PVC pipe versus HDPE and different types of fittings, and tell me more about two-wire controls and satellite controls, and what's new and exciting in golf irrigation. And I have a lot of respect for golf course superintendents, because all I've done in my professional career is work in golf irrigation, and I've got a full-time job just keeping on top of things. So I can't imagine, the responsibility of a golf course superintendent with all the other things that are required in the job, maintaining the golf course, managing personnel and equipment, and seed and fertilizer, and just a whole agronomic component. So I'm always happy to work with golf courses to be their resident expert. Kyle just asked me to mention a couple of projects that I've worked on. As I mentioned, Marion, I've been thrilled to work on the restoration project at Baltusrol that is just wrapping up right now, and the Gilhance restoration also at Oakland Hills. And worked with my dear friend Jeff Corcoran at Oak Hill Country Club. He's a good Penn Stater. Was a lot of fun, and several other projects across the country. But I typically spend most of my time between Boston and Baltimore, working in the business. So Kyle, I'm just going to do a technology check here just to make sure we're okay. Can you still see my screen?
We're all good.
Okay, thanks. So I get an awful lot of questions, and I'm sure everyone in the industry talks about, PVC pipe and high density polyethylene pipe, which is well known as HDPE today, and has been coming on the scene very, very strong as of late, especially the last 10 years. I was able to do my first HDPE system in 1995 at Syracuse University's golf course called Drumlins. And we needed to come up with a solution to Drumlins because the golf course at Syracuse University is right next to a rock quarry. And the aftershocks from blasting out the rock was shattering PVC pipe and causing a lot of earth movement. And we needed to come up with a solution on what to do. And we chose polyethylene pipe back in 1995. And that system's been in now for some 25 years and has stood up really well. So it used to be known as a specialty product, and now it's more commonplace, and we're seeing it more and more. This is just a typical yard. This is an installation at Walpole Country Club, and you can see the white PVC pipe, and sometimes it's blue, but you see the sticks of rigid PVC pipe, and you see the coils of HDPE. And at this particular project, they elected to go with what they call a hybrid system, where they have PVC mains and HDPE laterals. And I'll get into a little bit of why they chose that. And that's not the solution for everyone, but it was certainly the solution for Walpole. So PVC has got a bad reputation over the years, and a lot of it is because of weak fittings. If you've all been in the business and you worked at a golf course in the summer, and you've had an old irrigation system, you've invariably seen this. And this is a PVC fitting failure on a 2-inch fitting. And they typically fail on the inside radius, as you can see right here. On the inside radius of a tee and elbow are typically the weakest points of a fitting. So it's not uncommon to see, after years of use, that weakening in those inside radiuses of tees and elbows, and they tend to fail. The other failure mode is quite typically glue joints, and it's typically not the fitting. It's really, quite frankly, it's the installer's error. And there's a lot of things that we've learned about PVC pipe and fittings over the years, and I'm confident that if we went into the Wayback Machine and installed things differently 20 years ago, some of those PVC systems still be very still be working well today. Other issues are like cracked bells and what have you, and often, there's two things that are a result of that. One is sometimes the unsuitable backfill material that causes wear and rubbing over time and abrasion and causes it to fail. And some of it's just bad pipe, just like you could get in any batch of bad equipment. So, other failure modes or something like this that you might have seen, and whole lengths of PVC pipe breaking. And that's typically a result of, water hammer and surge, especially when you see this, we call in the business this zipper type look to a pipe is typically a water hammer situation that causes the pipe to fail. So it's not necessarily the fault of the pipe; it's the fault of of how the system is used. I think we've all seen ductile iron fittings in the business. If you've been working on golf course, you've seen those. They became the prevalent fitting in the early 1990s, and we've seen them throughout the 90s and even today. If we have some really hot soils, or if we're using acid, perhaps the acid injection, sometimes the combination of the two or one or the other can weaken the fittings and cause some fittings to essentially, if you will, rot and fail, which is really not the fault of the PVC pipe. It's the fitting, but that's a pretty dramatic one that I saw in Florida on a project where, it completely obviously rot right through this tee and weakened the tee, and the tee failed. This was a golf course that had very, very acidic soils, and they were very, very, very hot soils. And it was amazing they could grow turf grass on the soils. I want to believe the pH was in the 4s. And it just started to rot the fittings, and they were having catastrophic failures on fittings. And I think you've probably all seen some what we call in the business tuberculation, or the buildup of iron ore deposits on the inside of a pipe. Quite prevalent in the Northeast when you drain an irrigation system and allow air to get into the system in the wintertime, and it kind of promotes some corrosion. And that corrosion is symptomatic in some fittings, and obviously those nodules can break off and get into sprinkler heads and cause sprinkler heads to stick on or plug nozzles and what have you. And then, the blame goes to the irrigation system or the piping system, when it's not necessarily the pipe. It could be just the fittings. Anyone recognize what these are at all on the phone? That's what you're looking at right there is an air release valve assembly, and these valves belong in any pipe, PVC pipe or HDPE pipe, and they're continuous acting air vents that, as air moves through the system and it rises to the air, typically travels towards the top of the pipe, it exits this air valve that vents the air and seals against the water so they don't leak. So as air is encountered on the irrigation system, it just vents the air continuously and automatically. It's just a very mechanical valve. Operates very much like a toilet tank would or does. These belong in an irrigation system, and back in the 1990s, we saw very few on irrigation systems. And an ugly rule of thumb is that you put them at high spots on an irrigation system where air can accumulate. You put them at dead ends where, again, air could be problematic. Quite frankly, the best practice is to put them every 2,500 feet on an irrigation system if you're on a straight line, on a straight run. And with an irrigation system typically having about 25,000 feet of main, well, simple math tells you you're probably going to have 10. You should have probably 10 of these on the golf course at least. And I rarely see them, and consequently, I see the effects of air hammer, and it's actually water hammer because the air vents so quickly and the water comes in behind it. And I see a lot of failures in pipe and fittings that are related to hammer, that if they had an appropriate number of valves on the system, they probably wouldn't have had some of those problems. So talking about fittings for a second, this is a collection of fittings going into a golf course, and you can see in the foreground, you can see those uncoated fittings, and then you see the blue coated fittings, and the blue coated fittings are epoxy coated. It's a fusion bonded epoxy process that they use today on the inside and outside of the fitting to make it more durable to soils, which again is predominantly the problem, but also to any really problematic water supplies by coating the inside of the pipe. So right there are the typical ductile iron fittings, and the blue ones are coated. So you can quickly and easily tell that you have the appropriate coated fittings. These fittings will certainly last a lot longer in more harsher environments, and are a solution to some of the earlier technology, if you will, of the 1990s and early 2000s, where we just had plain ductile iron fittings. It's the goal in our business, and I say our business, mine is an irrigation consultant, and golf course superintendents and future superintendents like yourselves, to use the best products that are available. So when you install an irrigation system, the goal is that after 20 years or 25 years where the sprinklers need to be replaced, and probably less than that, or the control system needs to be replaced, that the infrastructure, the pipe, the fittings, they're all good and they can be reused again. And in many golf courses, we can reuse them again because they used, good quality components and they weren't having any failures on mainline pipe. Lateral pipe that goes from the main to the sprinkler heads, well, that's another story that we'll talk about in a couple of minutes here. So there's just a typical fitting that's in the ground. That's it's a more modern installation today, using PVC mains with fusion bonded epoxy coated fittings. So an industry best practice today is to actually wrap those fittings, provide another barrier from the elements against the fitting. And it doesn't have to be fancy. This is just a poly wrap. It's something that they've done in the waterworks industry for many years, and it allows them to put ductile iron fittings in really terrible soils in the waterworks industry. And you basically just use this specialty polyethylene wrap, and they have different size wraps for different size fittings. And even though they're fusion bonded epoxy fittings, they'll use this wrap and they'll just basically wrap up the assembly like a Christmas present. Doesn't have to be watertight, doesn't have to be airtight. It just has to keep the soil from being in contact with the fitting, because that interaction, the chemical interaction sometimes between soils and ductile iron that promotes corrosion and can cause some problems. And this is a very simple and easy thing to do. It's very inexpensive, and contractors, are commonly doing it today because, again, it's just a best practice. So this is a repair job actually, and they just retrofit this whole assembly here and wrapped up the fittings and just used some specialty wrapping tape. Just looks like duct tape works as well. But again, just to keep the material off the soil off the fitting. Does anyone have any questions or comments? Or okay, I'll keep moving along. So poly pipe, HDPE, we see it all the time now. In fact, I will say that on the lateral side of an irrigation system, which means the pipe from the main line, the big trunk lines to the sprinkler heads, it's almost exclusively HDPE today, high density polyethylene, and for a lot of reasons, and a lot of good reasons. One is you can get coils. These are 2,000-foot coils there. That one big coil in front of us is over a mile of pipe. They also have 500-foot coils. They also come in sticks or lengths of 40 or 50 foot, which is very desirable as well. The 40 to 50 footers, of course, obviously is considerably different than the 20-foot lengths you'd get with PVC. So there's fewer connections. So that's pretty desirable. So we typically see that a lot on projects, and I think you're going to see more and more of it on the golf courses that you go out to and work on and service and maintain as you move forward in your careers. You could do a lot of good things. You could do a lot of neat things with the HDPE. These are different fittings and different reducers. So those are two T's right there, and then you can see there's a reducer on that T right there. And they're just fused, welded together. And Kyle or anyone on the phone, have you seen the process at all? Are you familiar with that at all through school, through college?
Yeah, a little bit through irrigation. Actually, we have our irrigation teacher, Brad, on here, or he was on here. We were able to see like a live demonstration over at the Birch campus last year at some point.
Fantastic. Well, it is something you're going to encounter. We're all going to encounter more and more and more. You're going to see, these types of fittings and this type of a procedure on your laterals, on new systems. and your mains could be either HDPE or PVC, and we'll talk about that in a minute on why you would use either one. But this is a sub-assembly, so these are just back-to-back tees with some reducers. And in this case, you can see that the fusing technician actually put his initials on there and a date, just as a kind of a best practice, you know, kind of like sign your work. If you're proud of your work, you sign your work. And they kind of give, you know, I joke around with the guys that they autograph them as they put them in. And you can do an awful lot of fun things out there, or neat things. So here, these fittings are considerably stronger than Schedule 40 PVC fittings, and they are not as subject to some of the hoop stresses that PVC has. And you can see right here in this assembly, you can see the butt fuse joints. And you basically end up with what they call in the business a monolithic system, meaning that it's just one piece of pipe, or mostly, or long sections of pipe, I really should say, because sometimes we have to use mechanical fittings. There's a big fitting right there. Get them all shapes and sizes, different kinds of connections. It's a project up in Colorado at the Roaring Fork Club. Had a chance to work with Timothy Zivatek there. And HDPE was the mainline pipe of choice because of the conditions. It's a very rocky site. The HDPE mains gave us a degree of flexibility if we needed to maneuver around any rock. It allowed us, if we needed to go a little shallower if we wanted to, because we don't have those 20-foot sections of pipe that wants to have some upward thrust and pull out of the ground. So you can get away with a little shallower bury if you need to. And also because of the climate, it has a little bit better, it's considerably better response to cold temperatures in terms of freezing water. Kind of an illustration, you could see how they were able to snake this pipe a lot better than you could PVC pipe, because PVC pipe is fairly rigid. You shouldn't deflect it very much. You should try to use fittings whenever you deflect and bend PVC to the best of your ability. But you can see right here, they've got a large main, and they're actually lowering it into the trench. And you can see the fuse welds here on the 40-foot sticks of pipe. And that's actually a fusing machine right there that's actually fusing those lengths as they go in the ground. So that's a tracked fusing machine. So it'll just move along on its tracks, just like an assembly line. And they'll fuse weld sections of pipe and lower it into the trench with a backhoe/trackhoe and put it in the ground. So that was a very hostile environment. And HDPE was the ticket there. There's that fusing machine. There's a gentleman there signing his work. That's a butt fuse joint that he just put together there, and assembling the system. For those that haven't seen, that's a bead. When you weld the pipe together, what you're actually doing is you're actually cleaning the pipe, creating a straight face, you know, on that pipe. That machine I showed you actually has a facer on it. It actually creates a true face. And there's a heating element that goes between the two pieces of pipe, and it heats up the pipe at a prescribed temperature, at a prescribed duration. And then they bring the pipes together and hold the pipes together for a prescribed number of minutes. And then you have this bond right here, and you actually have a bonded joint. So it's a little lengthier process than PVC, but you eliminate a lot of joints and fittings. And again, on lateral pipe, it's absolutely pretty much standard protocol these days to use HDPE on laterals, unless you have an existing PVC system that you're adding on to, and you may want to stay with PVC. So HDPE, you know, it's the good, the bad, and the ugly on anything. I mean, you know, workmanship is so important. The nature of the installation process is such that there's typically more time and care, or should be more time and care, putting together a HDPE joint than a PVC joint. If only we did put that kind of attention into PVC joints back in the day, I'm confident there'd be far fewer failures today than we're seeing. If they took the time and effort that they do to putting these joints together here, like this gentleman's doing, we would have far fewer PVC issues. But you can still have some failures on HDPE, and typically, I quote that, typically the failures are less catastrophic. You typically don't have a complete rupture in a pipe like you've seen on PVC systems. It typically starts off and manifests itself as a small little pinhole leak, perhaps on a bead if that wasn't done properly, or maybe a small hole on a pipe if a stone or a rock rubbed against the pipe and weakened it and caused a puncture point. That's what you typically see, and that's another reason that we use them on laterals today, is because we don't often see those catastrophic changes, catastrophic things. So here's just a quick little video you might be able to see. This is actually a bridge crossing. It's a butt fuse joint right here at Irondequoit Country Club in Rochester. Survived many years, but I mean, you know, an imperfect weld there gave us this kind of a response, unfortunately, and they had to go in there and cut it out and make a repair. You know, HDPEs, you got to be careful. I mean, this was damaged because someone just drove over it. Because it's available in long lengths and you can string it out across a property on a construction site, you know, sometimes it's difficult to get around the pipe if it's strung out. It's difficult to get a vehicle from point A to point B without crossing the pipe. And this is the resulting effect because someone drove across it and it was on a rock and created a stress point, a load, and damaged the pipe. So you just have to be careful. I mean, it's just like anything. I mean, you shouldn't do it, but it does happen on a property. So I put this video here real quickly. I think I can edit this. I'm pretty sure I can. Nope. So up at the top of the screen, you can see that vehicle right there. The pickup truck has got a pipe rack in there, and that pipe rack is a 2,000-foot coil of HDPE, and then it's got a contraption, a hydraulic lever on it that straightens the pipe, because I mean it's a coil of pipe. It's just no different than a brand new hose. When you get a brand new hose, you know, it just wants to stay coiled. So you have to kind of straighten it, reround it, because it could be flattish on one side, and you'll run it through hydraulic arms here that actually straighten it out. So that's all I really wanted to show here. This is a really hostile site, as you can see, and you can see in the background, we tried to go through with a vibratory plow, and we were just destroying the sod. So closer to the foreground, you can see we actually ended up coming and stripping the sod because it was causing so much damage, and we were putting the pipe in. I mean, obviously, you can do an open trench and an open cut, and we considered this at the property as well. But after we got through this stretch here, it was actually fairly clean. So I'm just going to run you right through this quick little video right here, and you can see that is pipe in the ground right there, and that's a vibratory plow right there. And they're actually laying in, you can see, feeding a 2-wire cable in that trench while they're bringing that pipe off the spool. So that's a vibratory plow with a wire chute on it, taking that 2,000-foot spool of pipe and installing it on a fairway. So many fittings you can use on HDPE. So on the lateral side, which is pipe typically 4, 3, and 2 inches, a lot of times it's 2 and 3 inches. You have the fittings, those 4 fittings on the right-hand side. And that top fitting is called a Filmac fitting. It's a compression fitting. That is, Kyle, you guys might have seen this in class. That's a fitting that we see a lot these days. We even see them on new installations, but some people use them just as repairs and add-ons to systems. The gray fitting right below it is just a simple service saddle. It's a saddle that you clamp over the pipe and you cut a hole in the top of the pipe, a specialty hole in the top of the pipe, and you clamp it on. The fitting to its right with the stainless steel outlet is a butt fused service tee, which I like to use on greens and on greens. So I have no mechanical.
I don't know if the slideshow or the picture stopped, but we're still on the same picture of the main line of the pipe with the truck in the background.
Thanks, Kyle. Thanks for. How about now, Kyle?
On my screen, it's still. If anybody else is.
Can you see the fittings now, Kyle?
No, I still see the pickup truck also.
Yeah.
Okay, thanks. Let's try this. How about now?
No, you may have to.
Yep.
Reshare the screen. I don't know if that will kick you out. Reshare the screen and then share it. Maybe refresh it.
Okay. I just closed the album and opened up the fittings picture.
Yeah, I don't know if it's stuck on screen. Try resharing the screen through Zoom. I don't think the photo. I think it's just Zoom. Maybe it's.
I'll just stop the broadcast and restart it.
Yep.
Okay.
And there you go. And should restart.
Great. Thanks, Kyle. How about now?
It says you're sharing the screen. It just says double click. Yeah, we just have a black screen right now. I'm not sure. Maybe try one more time.
Share content, share screen. Start broadcast, I assume.
Mm-hmm. Now maybe try going to your photos again.
Yeah. Hey, thanks everyone for their patience. Sorry about that. So I've opened up my screen, Kyle. Lateral installations, and then just show a couple design concepts, things that you can do with HDPE today that you can't do with, it's difficult to do with PVC. See. Sharing my screen. Sorry, bud.
No worries. No worries.
Wished I could Yeah. Hmm.
Would you be able to share it off your phone itself? Do you have that same?
No, I created a special gallery on my iPad, unfortunately. So,
As far as questions go, I just wanted to ask you specifically is like when you're working as like, the project at Marion, when you were working there compared to, Oakland Hills is doing the new irrigation system. Are you seeing similarities between like the two? Do you see like a lot of similarities between the two designs of, rebuilding that whole system? Or is it kind of unique within the environment of what's in the ground already to that course as like, you know what I'm trying to say?
I do know what you're saying. It's a great question, and I appreciate the question. At Marion, we had determined that we could not reuse the main line at that golf course for numerous reasons: some sizing, some location, some impacts to construction. And although the main was only about 22 years old, we made the decision that we couldn't use it over again. And then at Marion, we used a design where Paul Latshaw really wanted to have more control of the in his roughs. So we designed a system that would allow him to have part circles on the edges of his fairways into his rough. And a lot of times I call it U.S. Open rough, just because guys want to bring on and promote growth in their rough and get some water to it. And I saw Paul struggle with that when he was at Oak Hill back in the early 2000s. And I know that he wanted to address that at Marion. So we had a design, Kyle and everyone on the phone there, where we irrigated the fairways and they kind of had part circles lining the edges of the fairways throwing out into the rough. And then sometimes we had heads way outside in the rough throwing back towards the fairway, just again to create that effect. At Oakland Hills, another Gil Hanse restoration, beautiful project. A lot of fun to be involved with that project with Phil Kafari, great guy. We were able to reuse their main. The main was well sized just about everywhere. We were able to add about 4,000 feet of main to the golf course and reuse the main. It was in good health. Fittings were good. We had dug up and inspected some fittings and didn't feel that was at risk, so we went ahead and did that. And their previous system had been a sub loop, and if you know what the sub loop is, that means that you have typically 3 feeds into a fairway where you have this looped pipe in the fairway where you would shut off 3 fairway valves to isolate the entire fairway. So with a setup like that, there was a lot less hardware in the ground than that herringbone design. And that herringbone design is when you have individual lateral lines coming out into the fairway. So at Phil's at Oakland Hills, we reused the main, and we created a grid where we didn't have the part outs, but we had plenty of coverage in the rough, and the climate dictates some of that. I mean, obviously, up in Detroit's quite a bit further north than Philadelphia, and the plant water requirements a little bit different, and there's a lot of plant stress, of course, but it's a different, it's different. They have different challenges there. So it didn't dictate that we needed that. Those heads probably wouldn't get used that much. So they were a little bit different, Kyle, similar but different. The design we did, though, was interesting. It was something that I talked to Paul Latshaw about and got his input on, and we kind of collaborated on. We decided to go with an outside greens loop where we actually came off the main and we ran a 3-inch loop outside of the bunkers, outside of the green cavity, and ran these 2-inch spurs up to the sprinkler heads on the greens. So it's a 3-inch loop, 2-inch spurs with a 4-inch feed. So from a hydraulic standpoint, we could put a lot of water into the greens when we wanted to. We could do a soil spray and turn on every head on this green if we wanted to. And the rationale is there were some very, 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 very narrow corridors between the bunkers that Mr. Hance was bringing up to the green. So there was a very small fringe there, and Paul did not want the pipe in that small, tiny little interface. So we went with this innovative concept with so some people call it the wagon wheel. It's something that you can do with HDPE a lot easier than with PVC. So we went with this wheel with spokes. One of the reasons too is these guys deep tine, and I don't want to refer to pictures that I don't have right now. And I had a picture of Jeff Corcoran's green number 1, where they'd done some drill and fill, and you could see how deep people go sometimes. And you just got to get the pipe out of there and be out of that interface. So we felt that running spurs up to the greens dramatically reduced the amount of pipe in and around the green cavity. So that was our goal there. So it was quite successful. And over time, if there's greens expansions, and there's some other great clubs out there that I've seen do some greens expansions over the years, and if you don't get that pipe outside of that cavity, that pipe could end up in your green. And there's a couple of very famous courses that I know of that have pipe in the greens, and it just is quite unsettling to know that you got that pipe right underneath the green. So we wanted to get it out of the way, Kyle. So that was the big difference there. Both golf courses elected to go with 2-wire systems as well, and move away from satellite systems to 2-wire systems. And that's a common thread. That's something I was going to talk about. We see that more and more today. Far fewer satellites going in. In fact, I think the last time I designed a satellite system was 2016. Everything's 2-wire these days. And a lot of it is because of the ability to expand the system, the massive amount of flexibility that you get in the system, and just the sheer fact that you get away from satellite controllers.
You kind of led into my next question. I was going to ask about Oak Hill and kind of the whole irrigation reconstruction of the green complex compared to what you were moving into off of the fairway lines and main lines. How did that kind of influence, instead of, not redoing necessarily or, mapping the entirety of the system, but just kind of taking the greens complex of it and renovating it to what Mr. Green wanted?
Well,
or what was working?
That was a lot of fun too. Andrew's by the way, first of all, the work that he did there was spectacular, and it was just an absolute thrill to be there, especially having been working at that golf course for many years. He's done some great work. But Andrew's goal was to go in and redo the greens. It wasn't a blow up like Oakland Hills and Marion and Baltusrol has been. It was more of a well, I hate to say nip and tuck because there's no nip and tuck. It's significant construction took place, but it didn't impact the fairways so much. So we did the same thing there, Kyle. As you may recall, we did the outside wheel with spurs up to the green. Those greens turned out to be absolutely fabulous. Massive putting surfaces, a lot of fun, a lot of character, a lot of challenging shapes to get sprinklers on. Because if in my perfect world, you'd build the greens a 65-foot square, because I could put heads at 65 foot square, nice and easily for you. So it became quite a challenge, and it was neat to see what Andrew Green did there. I mean, stunning work. Now, from an irrigation perspective, there's still meat on the bone on that irrigation system. There wasn't time to get rid of the irrigation system, so we did the greens. We modified some fairway irrigation where they moved some bunkers, and bunkers impacted piping. We had an irrigation contractor there from pretty much day one to the last day that would come in and temporarily demolish or cap the system that was impacted by an area of disturbance. Let's say a new bunker complex. We'd go in and we'd cap that and allow the contractor, the bar construction, to go in there and do their work, and then go back and restore irrigation in that place. And then in many cases, respace sprinklers so they actually fit back in the pattern better. But that was neat. And as you know, they pretty much have two new golf holes there, 5 and 6. So that was quite a bit of new irrigation going in there as well. Now, at Oak Hill, those that have satellite systems might find this interesting, that Oak Hill has these buildings, these structures across the golf course, and they run all their wires to those buildings, to those structures, so you don't have those satellite boxes across the golf course. So when we needed to add sprinklers, it was fairly challenging because there wasn't a local controller that we could go right up to a controller. We'd have to run the wires all the way back to a building. So that became a challenge, but something we worked around, and it worked out quite well.
So Paul, as far as students coming into the industry, kind of looking for internships, as far as the golf industry side, what would you recommend if students are looking to kind of get more of an irrigation background? I know you said that you kind of went on a different path instead of becoming a superintendent. If you wanted to talk a couple minutes about what interested you.
I would love to. So I got bit by the irrigation bug and just found it fascinating. Still do. Still really enjoy going to work every day. It's just a fun business, and you get to work with some fantastic people, which is really enjoyable. And everyone knows the big name golf courses, and there's a lot of golf courses that I work at that I always say a third of the courses you probably heard of, a third you might have heard of, and a third you don't know. And they're all wonderful. It's just fun to be out there irrigating golf courses. My advice to anyone in the business, any student, is learn as much as you can about irrigation, because I know I'll probably sound biased. I'm an irrigation guy, but it's the lifeline. I mean, we used to talk about the turfgrass plant being 90% plus water by weight, and you've got to get water to it. You got to get water down there uniformly and evenly. You're gonna have problems, and it's gonna pretty much happen in June and July when you need it the most. So any kind of experience you can gain on irrigation is absolutely fantastic. So I would dive into it the best you can. And there's lots of ways you can learn too. There's a lot of good irrigation vendors out there that can give you some time and give you some training. But I would get your hands on that as soon as you can, and learn as much about irrigation. I enjoy working with interns all the time. I'm working at Cays Valley this year with a couple of interns, and up at Oakland Hills, they had several interns from different places, and a good superintendent, in my opinion, and will get their team out there working with an irrigation consultant if he's on site, or an irrigation contractor, expose them to that, expose them to the irrigation side. Because I left college and I learned I knew electrical systems, I knew hydraulics, I could size pipe, I could do this kind of stuff, but I did not know how to repair anything. So I learned that, the School of Hard Knocks, and unfortunately the School of Hard Knocks is something that's probably going to fail after 2 or 3 years because it's triage. I didn't know how to fix things properly, didn't know what fittings were available. So I'd strongly encourage you to try to learn as much as you can. And if there's a very strong irrigation technician on the property, try to shadow him the best you can and learn from him.
Awesome. That sounds like a lot of good information. I know the first time we met, Paul was able to give me a little bit of irrigation experience with you and Gary, and a year later we're at the same course again. But so Paul, we'll wrap things up here. I don't know if anybody else has any questions further. I will give all the students. I'll send out all the students your contact information, as well as Mr. Jabikowski, our irrigation teacher. He was looking to get your contact information as well. And so I'm guessing I'd like to pick your brain for a little bit. But
if I could just say something to that, I've seen some of the things that he's doing through just following him on Twitter, and I think it's absolutely fantastic. Some of the stuff that I wished I had been exposed to when I was a student. So yeah, that's good stuff, Kyle. Thank you. Thanks for passing it along. And I've really enjoyed working with you, and look forward to running into you at another project sometime soon.
yeah, hopefully maybe we'll see each other Thursday. But if not, I'm sure we'll run into each other in the future. So if there's any last questions, we can wrap this thing up around 7 o'clock. Paul, thank you again for taking the time out of your day. I know, sorry, as far as
oh yeah, I'm sorry about the technical difficulty, everyone. I apologize. I apologize for that. I will say, if anyone has any questions, if I can ever help, I'd love to help. Don't hesitate to drop me a note and ask me a question, and at least I can steer you in the right direction. Thanks, Kyle.
Thank you. Thank you. Does anybody have any questions? I know we have a couple students in here who worked at the courses that you've been at recently. I know Aiden's from Oakland Hills. He was there this past summer. Clark,
oh, yeah, I remember. Yeah. Who else?
Clark, I think he was at the Roaring Fork Club.
Oh, wow. Yeah, sure. Well, they must have enjoyed some photos. Beautiful place, Roaring Fork Club.
Yeah, it's absolutely beautiful, and the irrigation system is working perfectly out there.
Hey, good to hear. Good to hear. That's great. Many people don't know that that Colorado is high desert, and that plant water requirement up there is pretty incredible. You're socking water to the place all the time. I mean, it is high desert. It's you're close to the sun. Your solar radiation is through the roof. It's quite incredible.
Yeah, it definitely was a challenge this summer. It's spent a lot of time hand watering for sure. So.
Well, I bet. Yeah, put your sunscreen on, right?
Definitely.
All right.
Well, thanks, Kyle.
Stop the recording. Thank you, Paul.
Hey, all the best. Hey,